So we're going to use properties of logs to expand and condense some log expressions. So this is pretty easy and straightforward. You just remember the three major properties of logs. So if you're expanding, you're going to have a series of sums and differences of logs. Basically, if you're whatever's on top um, would be positive, a plus, and their exponents will can come down in front of the logs, and whatever's on the bottom of the fraction, like the z, will be a minus log, and its exponent will also come down in front of that log. So it's the key here is just to make this as easy as possible and to do these as quickly as possible. So the x is up top, so it's a positive log base 3 of x, and that exponent 3 will come down in front of the log. The y is on top, so it's positive log base 3 of y, and then its exponent of 4 comes down in front. And then the z is on the bottom, so that's going to be a minus, because when you have a log of a quotient, it's a minus. And z is the fifth root, so remember that's z to the 1/5 down there. So its exponent is 1/5, which should come down in front of that. And we are now done with that problem. That's all there is to it. Do the same thing with this one. The one thing on this one is that x plus 5, that's just and the x minus 4, those are single expressions, so you just keep those together. You can't log across a sum or a difference, only across a multiplication, the x times, and the division, the divided by x minus 4. So you have to think of this x minus 4 as what you're dividing by, one single term. So to expand this, it's positive natural log of x, because x is on top, and that's to the first. This cube root indicates it's x plus 5 to the 1/3. So that's up top, so it's plus natural log of x plus 5, and its exponent comes down to 1/3. And then minus, the x minus 4 is a single term on the bottom, so, or a factor you can call it. So it's minus natural log of the quantity x minus 4. Make sure you use the parentheses there, and that is it. So that's pretty easy. That's expanding. Condensing to a single log is just the opposite. So remember, you're going to condense, and this will be a single logarithm. So the first thing I'm going to do for number 3 is it's going to be a log base 5. And I guess it should be mentioned that all these bases need to be the same for this to work, 5 and 5 and 5. So I'm starting with the log base 5. That's my single log. And I'm just doing the opposite. This is a positive 4 in front of this log, so that will be the exponent of the x. So since it's positive, it's x to the 4th up top. We have minus 3 log base 5 of y. So this would be y to the 3rd. It takes this exponent, but it's on the bottom because of this minus. And then we have a plus log base 5 of z. So that means the z is going to go up top, and it's going to take this exponent, 4/5. And we're done. Simple as that. So you can see we created one single log out of a sum and difference. So finally, this one. This one is a bit trickier, but not really. You could just do, it's 3 times this whole quantity. You can just do this entire, condense this entire inside part and then deal with the 3 later. But usually in this situation, it's much quicker just to distribute that 3. So it'll make this problem a lot quicker, I think. And 3 times negative 1/6 would be negative 3/6 or negative 1/2. So now we're going to go from here. And now this is just almost exactly like the problem before it. The x minus 2, the x plus 3, and the x minus 7 keep as one expression. Again, you can't distribute a natural log. That doesn't make any sense. So we're going to condense this to one log. In this case, it's log base z, or natural log. The x minus 2 will go up top because it's a positive 3 natural log. So we have x minus 2, and that gets raised to the third. The x plus 3 also goes up top because it's positive. So times x plus 3 to the ninth. And finally, the x minus 7, since it's a minus log, will go on the bottom. It's to the 1/2, so you can raise it to the 1/2, or that's the square root. It doesn't matter. But notice that all those, the x minus 2, the x plus 3, and the x minus 7 stay grouped within the log. A big mistake is people accidentally put a plus up here, but it's not. It has to be all multiplied, just like this one was. So make sure you don't do that. These are easy. It takes a little bit of practice to get used to it, but once you do the practice, it's just really simple, and it should be. So that's that.